We are going on with KCSE revision. This question number 1 is a question on nitrogen and its compounds. The question reads, the setup below shows the catalytic oxidation of ammonia in the laboratory. And this is the setup. The first question is asking, state and explain the observations which are made. There are two main observations which are made in this setup. The first observation is on the nichrome wire. So the nichrome wire glows red. So that's the first observation. We are supposed to indicate the observation and the explanation. Why is it glowing red? It is because the reaction that is taking place on the surface of the nichrome wire is highly exothermic. The reaction that is taking place on the surface of the nichrome wire is highly exothermic. So there are two things which are expected. This question is 2 marks. So the first mark will be for the observation, and the second mark will be for the explanation. So glowing red is the observation, and explanation is the exothermic reaction which is taking place on the surface of the nichrome wire. That is the reaction between ammonia and oxygen gas. The second observation are these lines that you are seeing here. Those are brown fumes, okay? Brown fumes of nitrogen 4 oxide. So that's observation number 2. Okay, how will we explain these brown fumes? We'll explain it using the reaction between ammonia and oxygen. This ammonia here and oxygen here. So when ammonia reacts with oxygen, they'll form nitrogen 2 oxide and nitrogen 2 oxide and water. Now the nitrogen 2 oxide will be readily oxidized by oxygen which is present on the flask to give us nitrogen 4 oxide, which is red brown. Okay. We have said that we have two main observations. The first observation is the red glow. The second observation is brown fumes. For each observation, we are also giving explanation. So for the purposes of an exam, if a student writes nichrome wire glows red without writing about the brown fumes, that student still scores the 2 marks. So the first mark is for the observation, and the second mark is for the explanation. Are we together? So in this same one, brown fumes, that is observation, and then due to reaction between oxygen and ammonia to form nitrogen 2 oxide. And what? Steam. Then the nitrogen 2 oxide is oxidized to nitrogen 4 oxide. By what? By air, which is present inside the conical flask. Okay? That is it. So we go to the next. Write a balanced chemical equation for the first reaction taking place in the conical flask. So here we have the conical flask. We have oxygen, we have concentrated ammonia. As oxygen is passing through the concentrated ammonia, ammonia fumes are produced. The ammonia fumes will react with oxygen on the surface of the nichrome wire. Now what will be the products of the reaction? So there will be two products. The first one is production of nitrogen 2 oxide and steam, and the second one will be the conversion of nitrogen 2 oxide to nitrogen 4 oxide. But which one do we require? The first one. So we write the first, and that is what is expected of us, but we'll also write the second one so that you can also know which is the other reaction that produces the brown fumes. So the first reaction is this one. Ammonia reacts with oxygen to give us nitrogen 2 oxide and steam. Nitrogen 2 oxide is colorless, but the fumes produced here are brown. How are these brown fumes produced? It is due to oxidation of nitrogen 2 oxide here by oxygen to nitrogen 4 oxide, which is now the second equation. So this is the equation. Nitrogen 2 oxide reacts with oxygen to give us nitrogen 4 oxide. We balance nitrogen 1, nitrogen 1. Oxygen 2 plus 1, 3. Oxygen 2. So how do we make this one 2? By multiplying here by a half. Then we remove this fraction by multiplying all sides by 2.
By 2.
So here we have 1 times 2, it will be 2. Here you have a half times 2, it will become 1. And then, so the chemical symbol represents 1. And then here we have 1 times 2, it will now become 2. So you can see how the color has changed from colorless to brown. Nitrogen 2 oxide is readily oxidized to brown nitrogen 4 oxide by oxygen, which is present on the conical flask.